So, hi there, welcome to my talk, Event Sourcing Do It Yourself, and why I think that it's important that you actually do it yourself and on your own. I'm Roman, and just for my introduction, who I am. So at the moment, first and foremost, I am a father of two beautiful 4-year-old twin girls. And I took this picture because this is like a couple of weeks ago at my birthday, both of them learned to ride bicycle at the same time. And for me, it's pretty important that this notion of learning and learning all the time. So this was kind of a good thing at the moment. And for me, it's learning is. I learn best when I tell people or when I share my what I've learned, and that's why I created a YouTube channel called called the DevOwl. Which is at the moment mainly about F# programming. So if after the talk you're interested in learning more about F#, maybe you can check this out. I also founded a user group, F# Osnabrück. It's in the west, small city. So if you're close by, there will be a couple of more meetings in the future. That's about me. And the question is, who are you? So the first thing, because you attended my talk, is I think you're beautiful. Thanks for being here. But for this talk, more important, I think, is that you're curious. And maybe you've heard about event sourcing, you read about event sourcing, maybe you used it, and maybe you have a lot of questions. But you're here and you're at this awesome conference, and I hope that you're curious people that really like to learn about this stuff. So what are we going to do in this talk? So first of all, I want to give you a quick recap what event sourcing actually is. I want to give you my motivation or the motivation why I think it's important that you do it on your own. And then I will give you a small and nice domain in which we are trying to implement, or I'm going to show how to implement a lot of stuff that you might need for event sourcing. So there will be some code. The code will be in F#. So if you have no clue about F#, don't be scared, because first people leaving, that's okay. So that's the last last option here. So if you're really scared about F#, don't worry. I try my best not to go into too many details, and you can see it as pseudocode. And I think that all of the concepts translate very well to C#, JavaScript, or PHP, or Java, or whatever other languages you're using. So I want to start with what is event sourcing. So who has ever heard about event sourcing? Who has ever read about it, read some tutorials, some videos, watched some videos? Okay. Who has ever tinkered around with it, like a pet project or something? 3, 2, 4, 5. Who uses it in production? What are you doing here? No, thanks for being here anyway. So, to be able to tell you what event sourcing is, I think the most important question is, what is an event? So what is a domain event, actually? Anybody?
Something that happened in the past and has a meaning for domain.
Thank you. For the domain or for the business? Okay. Exactly. So a domain event is something that's happened in the past and that it has a meaning for the business. And I think that with events, we can model our business really well. And I think that events are fundamental for business processes. And you can describe business processes with events pretty good, I think. And therefore, I think that events are fundamental for our business processes. And if we accept this idea, I think the next step is pretty logical, that we also model with events. We use event storming or whatever other technique to model our business or our domain with events. And if we do this already, and we have done our modeling and we get some events out of it, it might be the next step that our software also needs the events as their foundation, so that we use the events that we found out for our business in our software. And the big thing with event sourcing now is that we don't persist the state of our application anymore. What we are actually doing is that we only persist the events that happened in our domain. So we get a stream of events that is immutable, hopefully, so we don't change it anymore because it's something that happened in our business, but we don't persist any state anymore. And that's the big thing about event sourcing. But that's it, actually. So it's not too much, I think. So what do you mean when I say that we persist only the events? This is something that we do all the time when we have a relational database. We say update customer set street is equals Baker Street, for example. But what we lose here is the intention. Why did we do this? Why did we update the customer to Baker Street? There could be many possibilities. For example, and we have an event here, we could say that the customer moved. This is important. But we could also say that the address was just corrected. So the intention of this action is pretty different. But when we just update this like this, we lose all the intention why actually something happened. Because I think there is a big difference when the customer moves. Maybe the customer now needs different advertisement for a different area or something. But when the address was only corrected, nothing new should happen in our business, probably. So I think that event sourcing is awesome. And there are a couple of things why I think that it's awesome. So the first thing for me is that we don't have a database scheme, and therefore we don't have a migration. So if we have a business application and we have a relational database, we modeled our system with the relational database in our head, somehow at least. And when we have a different or new version of our system, what is always has to come with us into the new version? The data. I have never heard of any business that says, okay, you got a new version, version 2, and now we're using Elasticsearch and no MySQL anymore, but just forget about our data. It's not, so our past is not important anymore. So you have to somehow migrate all the data into the new system. But if you have only events that are only describing your domain without the third normal form in mind or something, it's much easier because you can then project the events into your new database or whatever much more easily. The second thing is that we have no loss of information due to destructive actions. So what is a destructive action in a database? Delete. Update, delete. Yes, delete, of course, because we get rid of data. Truncate table as well, maybe, but update as well. But also, I would say that an insert is a destructive action. Because what do we lose here again? The intent. The intent of the business. We lose the information why I inserted this stuff. We don't need any more ORMs. So I also thought I found my silver bullet with a nice ORM, and this silver bullet got rusty pretty fast for me, and we shoot ourselves in the foot as well. So I'm not a big fan of ORMs anymore, and we don't need this mapping from objects to relational database, and we don't have any impedance mismatch anymore. It's possible that now, because we just collected or stored what happened in the past, it's possible that we get a different interpretation of the past. That our business says, now we want to analyze our data a bit differently. You can do this as well with a relational database. But the thing is that you don't have the history of everything that happened before, so you can just start to use your new analyzing or BI system on new data that is coming in. if you have a 2-year, 5-year, 10-year-old history of everything that happens, you can use your new analysis immediately and get a lot of stuff out of it. It's possible to build what-if scenarios. What is a what-if scenario? So it means that, for example, I want to plan a schedule for a conference like this year. And I want to see, if I put this speaker into that room and this speaker at that slot into this room, how would my whole system look like? This is pretty easy with events. You can just give some events to the system and say, just imagine we had these events. How would the whole conference look like? So it's pretty easy to build just a sandbox where you can say, okay, now I have done everything. Now I don't like it, scratch it. Now I have done everything again, I really like it, so put this into our system. This is much easier than with a relational database, because if you read and write into the same database all the time, you really need to think hard about sandboxing and that I don't put something into my life system, for example. And if you go later on, maybe full-blown CQRS, and you have different read and write models, so you write into a different place than you read from, you can optimize the performance pretty good, I think. So Greg Young, the guy that coined the term CQRS and who is a strong proponent of event sourcing, says event sourcing is easy. It's very easy. Don't have to do so much. Because what is it? It's just a function from a state and an event to a new state. That's it. That's all there is. Jeremy also says, yeah, maybe I would add that I have a state and a command, and I get back an event, because he's Français, so there's the accent on there, but no, but if you do this, you're more into the message-based and maybe CQRS system. For now, we just want to concentrate on this. So it's very easy, he says, to do event sourcing. Might be a bit condescending if you say, you don't have to think about it and it's so easy and why don't you get it right, but that's the notion. He also sometimes says event sourcing is just the left fold over all the events. Deal with it. Go on, okay? So I will talk about this later. But then you start with event sourcing, you start to read about it, and you read all the blog posts, and people say, but you need to really think hard about versioning. What is, if your domain events are actually changing, how can you cope with this? And now you have suddenly eventual consistency because you need to project all your events, and it's really hard, and now your business doesn't get the information immediately. And it's slow, because what if you have 1 million events for one aggregate, and you have to replay it all the time, and it's horrible. And then it's all asynchrony, and as we all know, asynchrony is horrible to deal with, and maybe you have different threads and whatever. So, and at that point, those awesome frameworks come into play. And they promise you a lot. And I just picked a couple. For each possible language or system, there are frameworks available. So you have, for the JVM, you have Axon, which is a framework for scalable high-performance application. You have Proof for PHP, which is an enterprise-ready CQRS and event sourcing packages, blah, blah, blah. You have VolcanKit for JavaScript. You have the event store of Greg Young, which is mainly an event database, but also has all the projection stuff in it. And you can even use something like Akka with the actor model. And they promise you a lot. And the first thing that they promise you is that they are production. They're even enterprise ready. So you could use this in your enterprise directly. It's awesome. And it will work out of the box. And the cool thing is, if it's enterprise ready and it will work out of the box, the nice thing is that you don't have to learn it. Because the framework just gives you everything you need. So you can't really shoot yourself into the foot, right? Because the framework is there to help you, to carry you. That's what it's doing. But the thing is, what I think, event sourcing is different than using an ORM, using a relational database. It's just different. And if something is different, you really need to learn it. So Alex of Proof, I actually used this Proof thing for quite some time when I was still doing PHP a couple of years ago. People say, hey, it's so complex and you do it wrong the first time. But you know what? Everything you do the first time, you do it wrong and you get it wrong. So better practice it. But if you practice it maybe practice it not in a critical project. But those frameworks say they're production and enterprise ready, so they lure you a bit into this notion that you can use it. And what Matthias or Eric actually said is, production code is the most expensive code you can write. You know, better just prototype and check the prototype away, trash it, and use it again, and learn from your mistakes. Don't put it in production immediately. So. If you take one thing out of this talk, then it's this quote, I think. So if you use a great and scalable solution to a problem you do not understand, you have just created a bigger problem for yourself. Because it's much harder later on to work around all the solutions that this framework, for example, or some system gave you, but it's not tailored to your needs, and you have to work around a bit in the end around your framework. So what I propose is just learn and do it yourself. So what do I mean with this? There is an arrow, you see this, but it looks a bit different on my machine. Prototype. Prototype, what do you need? Tailor this to your needs. Throw it away. And then repeat. And then repeat. Okay? And iteration and refinement will produce quality in the end. I promise you this. But you have to learn. You need to understand what your problems are. And then you will find good solutions for this. So I want to implement event sourcing now, because it's great. So what do we need for event sourcing? Events, projections, read models, commands, behavior, snapshots, because it's slow when we replay everything. We need the cloud, for sure. We need Saga, CQRS, event store caching if it's too big. We need a unit of work to throw things away if something gets wrong in the middle. We need versioning. We need everything. No, we don't. What do you think, what do you need for event sourcing, first and foremost? Thank you. And I think I like to work in functional programming languages where everything is pure and there is no side effect. But a program without side effect, it's not really useful because it's not doing anything besides of heating up the CPU. So we need a side effect. We need to somehow store the events. So I think we also need an event store. And that's all we need for the beginning, I think. So I want to introduce the domain we're talking about here. And it's a domain that I hope and I think that everybody can relate to or likes, and it's about ice cream. So it's about an ice cream truck. And we modeled our domain of an ice cream truck. It's a simple domain, of course, because we only have like 42 minutes left. I can't go too deep. But we modeled our domain with events. So we have, for example, an event that the flavor was restocked. And that event has two attributes. Which flavor has restocked and how far it was restocked, like how many of the portions have been restocked. We have an event that the flavor was sold with the attribute a flavor. We have an event that the flavor went out of stock. So the ice just sold the last portion of my flavor. And then we also have an event that the flavor was not in stock. And this is, for example, one thing where you need to learn to think differently when you're doing event sourcing. Because what would most developers normally do if the flavor was not in stock? They would throw an exception, right? Because a flavor was not in stock exception, maybe even an invalid argument exception with the text flavor was not in stock. But it's an exception. But is it an exception? Why should it be an exception? It's something that happens in the business every day. Somebody wants to buy vanilla and it's not there. What does the ice cream truck do? Throw an exception? Just flip around? You know? So you can't really do this. So this is expected behavior in the domain. So it's an event in the domain. And this is something you need to learn. Of course, there are cases for exceptions like memory, out of memory exception or API not reachable, whatever. But this is within your domain. It doesn't matter here. So now I'm going to show you the first part of F#. So don't be too scared. And what I'm going to show you is how to take those events and model them in your system. And that's it. So we can actually just take those events and write them down. So what is this here? It's called discriminated union. Crazy name, but it's not so hard. It's just an enum. People say enum on steroids. So we have all those events with these cases. Flavor sold, flavor restocked, flavor went out of stock, flavor was not in stock. And why is it an enum on steroids? Because each case can wrap different kind of data. So for example, here the flavor sold wraps some flavor. And the flavor itself is also a discriminated union. It has two cases, a vanilla and a strawberry. That's it. We described our whole domain. We don't have any more flavors because it's a small ice cream truck and we just want to get started. And there was no more space on the slide. And the flavor restocked actually wraps two values, a flavor and an integer. If there are some signs you don't understand, it doesn't matter. But I think you can read it. It's a flavor and an integer. Flavor went out of stock, a flavor. So this is a type. And these are cases of the type. And the nice thing later on with pattern matching is that we can always tell with which case the thing was created, the type, and we get the data out of here. And how do we actually create an event? It's just a function call where we say flavor sold. So this is also it's a description and also a constructor for an event. So it's called flavor sold with the type vanilla. So now we have an event, flavor sold vanilla. One of the vanillas was sold. And this is how we define a variable or an identifier in F#. We say let event is something. So these are our events. With a couple of lines of code, we have described our whole, given very small, but our whole domain. Now I said we need an event store. I'm not going to show you the code of the event store because it's not that important here. Because an event store is only an append-only data structure with two functions. That's it. You can implement this in every language just with an object or a class and an instantiation. So these are two functions. Get, which is a function that does not need a parameter, and returns a list of events. So this is the list syntax, so to say, those brackets. And it's an append function, which gets a list of events and returns nothing. That's it. So it takes them, appends the event to the store. You can implement this in any language, however you like, just an array, whatever. In F#, here I use something which is similar to an actor, but it really doesn't matter. So we can put this into F#. We say, okay, we have an event store with two functions, get and append. Void in F# is called unit. And it returns an event list, and append takes an event list and returns nothing. Why is this little thingy up here? It's generic. So you have this in C#, you have this in Java, your big T or whatever. You might get this in PHP even at some point. So it's an event store that takes some kinds. I could also call this T here. It's just a name in this case, but it's just a name, better take a good one. And then we can implement this. So here, this is what I said. This is F# syntax. If you miss your curly braces and everything, just ignore it. So we somehow initialize our event store, and we call a function self flavor with our vanilla flavor, and we give it also the event store. And when we do this, here just for your, that you remember the events, we call the event store append function with this dot syntax and give it a list of events. In this case, we have a self flavor function that takes a flavor and an event store, and the generic is filled with our normal events, and we give this to the event store. And that's it, pretty much. Of course, now you need to somehow memorize those events in your event store, but this is how you can start, I think. So I prepared a little UI for this so that I can show you that it actually works. So all the code in there is actually working, and it's actually in my examples. I needed the UI for this, and what is the most beautiful, imaginable UI you can think of? Of course, it's the Windows command line. So, yes, it is. Yes, but it's beautiful, isn't it? Okay, we have 4 steps, just that you can prepare yourself, but we just start with the first one. So what do we have here? We have 2 possibilities that we say append a flavor salt vanilla event. We say we have append flavor salt strawberry, and it's a list of events. So it's also possible to just give it 2 events or 3 events. It makes no sense to have a list and only put one thing in there. So we could say, okay, we have flavor salt strawberry, and this was the last one, so we say empty. Up there we see that the history of our event store is 0. So if I append this, I have a flavor salt vanilla in my history. If I append this again, the event gets appended, flavor salt strawberry, and then those, another strawberry, and the flavor went out of stock. But now we want to work with this data. This gives us nothing. We just have stored some events. So we could write some code that gives me the salt flavors down there. So it says salt flavors vanilla 1 and strawberry 2. Is this correct? Yes, this is correct. So the vanilla, we have 1 event that says that we have salt vanilla, and 2 that we have salt strawberries. So, oh bloody hell. Sorry. So how do we actually, this was the example, how do we actually use this data? What have we done with the information that is stored within the events? We used a projection. Projection is another concept that I think is pretty important when we're doing event sourcing. And what is a projection? A projection has 2 parts. It has some initial state, and it has an update function, which is it takes a state, takes an event, and returns a new state. Does this sound familiar, maybe? Break everything here. I'm sorry. Does this sound familiar? This is actually exactly this, what Greg said. So we take the projection for some state and for some event. We have some init function, some init value, which has just the state. And we have an update function which takes a state, takes an event, and returns a state. If this looks strange to you, that there are 2 arrows, just ignore it and think that it's like all the parameters before the last arrow are input parameters. That's it. So that's a projection that we have. So how does the code look like to build such a projection actually? So for example here, we have a salt flavors projection, which is a projection which has as the state, because the state is the first thing here, as the state has a map. A map is a dictionary. Dictionary, I think everybody knows what a dictionary is. So it's a data structure that has a key. In this case, the flavor is the key. So vanilla, for example, and an integer, how many have been sold. So it's vanilla 1, strawberry 2. And it takes events. So the initial value is an empty map, and the update function is this update salt flavor function, which is defined up here. What we're doing here is we take the event of the function and do pattern matching. This is what pattern matching in F# looks like. So we say, if it was a flavor salt event, we take the flavor out, then we say, okay, we have the state, which is a map, a dictionary, find the flavor. If it's not there, then it was 0. And if it's there, I take the map and add +1 to it. This here is the lambda function, so it's a function that is defined inline in F#. I think also we have this in C# and we have this in in JavaScript and PHP and I think Java as well. But this, what we are doing here, is only for one event. But we have a history of events, right? We have a list of events that we want to project into some state. And this is the second part that Greg said, it's just the left fold. So let's just do a left fold. I mean, he's right. But what is the left fold? Who knows what the fold is? Who could just come up here and tell me? You don't have to, but come up here and tell everybody what a fold is. Who feels really safe? Just you. Oh, I put your thing on it. Okay, 2 people. Okay, so what it's doing is it takes all the events. It's a list, so we use the list fold function, and it gets 2 parameters: the update function in the initial state. And it returns a new state out of the thing. So let's play this together for once. So we have the init, which is an empty map. And we have our events: flavor salt vanilla, flavor salt strawberry, flavor empty strawberry, flavor salt vanilla. So the fold function now takes the update, which is given here, takes it and puts this as the input and the list as the input. And it returns, oh, now we have vanilla 1, because this pattern matching tries to find it. If it's not there, it's 0, and then +1. The second one is flavor salt strawberry. So we put the output of the first call as the input of this function, and we get, and this one entry of the list, and we get vanilla 1, strawberry 1. Now we put flavor empty strawberry in here, and this input. This says all other cases just return the current state. So it's all other cases because it's not flavor salt, it's flavor empty. So we just return it. And then we say flavor again, update with the flavor salt vanilla, and we get our final result, vanilla 2, strawberry 2. That's all there is to fold. It's not magic, but you just have to know what it's doing. But that's actually what we always do when we work with projections. So I hope that I convinced you that projections are also needed for event sourcing. But we haven't done anything yet, because we just appended events. There's no logic. So where's the business logic, actually? How do we actually have our conditionals? Which event should we give back when there was no flavor left, for example? So there are many possibilities to do this. In this case, I decided to use something like an event producer. What is an event producer? It's actually a thing you learned, I think, when you started with computer science, is input, black box, output. And in this case, it's the same. It's a history, which is a list of events, some black box, some behavior, and the output is another list of events, new events that happened. That's an event producer for me. I defined this. There's no literature. I think you can Google. But this is how, for this prototype, I define an event producer. So this is our old event store. We scratched that. And we define a new type here, which is an event producer. And this is exactly what is written here. We get an event list, and it returns an event list. This is where our business logic resides. It's completely synchronous. It's just a function. So we put a new function into our event store, and I called it evolve. So we evolve our history. And it gets an event producer, which is a function from events to events, and it returns nothing. So the events that come out of this are then internally appended to my event history. So we have this here. And this is what I've shown you earlier. We say, again, self-flavor vanilla with the event store. But now the event store, we don't want to use the append anymore because we want to have actual logic. So we say here, we evolve it with a function of the behavior module, self-flavor with the flavor. So how does this look like? The function returns an event producer, which is a function from events to events. So it returns an inline defined lambda function here that gets events. Then we do something, magic, to get the stock for this flavor. How many are left for vanilla when I have flavor salt vanilla? And then we do pattern matching again. If it's 0, I give back flavor was not in stock. If it's 1, I give back flavor sold. And the flavor went out of stock because I just had 1 left. And now I have 0 because I sold it. And in all other cases, I just have flavor sold. That's it to the behavior. But magic is always bad. So I think this is the important part here, right? How do we actually get the stock? So how do we get this information, how many flavors are left out of our events? Well, we have something that is able to take the history and produces a state, which is a projection. Thank you. A projection. Okay, so this is the function, the self-flavor function again. And here, what we are doing here, we use another projection, the flavors in stock projection, and fold over it. So we get a map, again, from the flavor to a number, how many are in there. And then I say, okay, now I have the map, now I want it for one specific flavor, so I try to find the flavor in there, and if it's not in there, then it's 0. And this is how I get this stock out of it. So we have the flavors in stock projection here, which is also a map, and the update is the flavors in stock. And what we're doing here is, again, the same thing. We just try to find it. If it's not there, it's 0. Otherwise, when we sold 1, we say -1. And we can put even more behavior in there. We can have something like restock, where we give an event like flavor restocked with some portions. So we restocked flavor with 5 portions. That's another event. There is no logic in here because I didn't want to blow it up too much, but you could also put something in here. If it's at max 20, then we can't restock it anymore because it's full, because the ice cream tug only has limited capacity. But here it's just the flavor restocked. And then I took the logic out from the former slide and have a restock. And in the flavor sold one, I say -1. And in the flavor restocked one, I say plus portions. So don't need to dive too deep into this, okay? We just try to find, we just defined a projection that gives me a map with all the flavors in the stock. So we need behavior. Otherwise, our whole application is useless. So I show you how this works. Without destroying my mic again, hopefully. Okay. So it was step 2. So now we have no history. And we say self-flavor vanilla. Flavor was not in stock vanilla. Because we don't have any. We didn't restock, right? So there is no. And if we have a look at the output of the stock off projection, we see that the stock off is 0, just down there. So if we say self-flavor strawberry was also not in stock. So now I say restock vanilla with 5 portions. Okay, now we have the event flavor restocked vanilla. So which means we shouldn't be able to sell strawberry because we didn't restock it. So we get flavor was not in stock. But what should we get when we say sell flavor vanilla now? Flavor sold vanilla. We didn't. Bloody, okay. Why is that? Okay, maybe again. Vanilla, no, it's not working. Okay, so we say stock of vanilla is still 0. Okay, something is not right. Let me check this. No. You trusted everything I said. And wouldn't it be awesome if we have tests for our behavior? Wouldn't it be awesome if our application would be tested before? I mean, this is a statically typed language. We don't need tests anymore, right? Obviously, we do, right? I just glanced over the code. It's not so important for you. You just didn't believe me that it's working. But it was not working. So, and the nice thing with event sourcing, I think, it's that it's so easy and I think a lot of fun to test, especially with a language like F#. So it's not BDD what we're doing here, it's just BDD style testing, okay? We're just using this given when then thing of BDD. So we have a precondition, which is our given. We have an action, some action, this is our when, and we have the outcome, which is our then. You know, this just, even if you're not doing any BDD or Gherkin or all this other stuff, I think this is always a good structure for your tests, given when then, always. Doesn't really matter. But I think that's really good. And the nice thing with event sourcing is that you can just map this directly to this thing here, because the given is some set of events. You don't need to mock any state into your database. You don't need to, you just say, I have these 10 events here. This is how my application looks like. This is what happened in the business. That's all there is to. And then we have some kind of action. And the output is another set of events. This is testable. This is really easy. There's no need for mocking for whatsoever. So when we take our example, we say, okay, we have flavor restocked with vanilla 2. And we have already sold 1 vanilla. That's our given state. This is where we start, actually. When we sell 1 vanilla, then what we expect is actually a list of 2 events, which is the flavor sold vanilla and the flavor went out of stock vanilla. That's it, right? And that's the whole thing about testing with event sourcing. And when you use a language like F#, where there's not too much noise and clutter with curly braces and everything around and commas, and which really enables you to write simple DSLs, you can actually take this directly into code. So this is the F# code that tests this. And this is a function called given that takes an event, a list of events, when we use our behavior function, sell flavor vanilla, then we expect the flavor sold vanilla event and the flavor went out of stock vanilla event. That's it. It's really readable. You can talk about this with your product owner. They understand this. I tried. It works. So what we actually done here, just to show you, I glanced over this restock function. I said, I tried to find it. If it's not there, it's 0, and otherwise I add it. But what this function actually does is it tries to find the value. If it is finding the value, then it calculates the new number. If it's not finding the value, it's not doing anything. So it can't never do anything because the initial state is empty. So this is what happened here. So we scratch this, fix our code, and say, okay, we try to find it. When it's not there, it's 0, and no matter what, we actually update the map. This is what was wrong here. So I can show you this here. I exit this. We go into step 3, sorry, and we say, okay, I have tests here now. Run tests. I run my test, and we see here that this is exactly what is happening. The event should equal expected events. The actual value was flavor was not in stock vanilla, but we had expected it to be flavor sold vanilla. This is exactly what I was showing you in the last step, and what went wrong, and what went also actually wrong while preparing the slides. So for me, and when I fix this thing, everything should be fine. So this is the fixed version now. So I still have sell flavor not in stock. When I restock it, now it should really work. I get the flavor sold vanilla event, and I see the stock of the vanilla is 4 because we have restocked it with 5, and I already sold 1 vanilla thing. So it's not necessary to do it when doing event sourcing, but it's necessary when you're programming. So I'd always put the testing in there, especially if it's so easy. Don't cheat on this because it will help you a lot. But maybe now you will ask, but where are my aggregates? You have one ice cream truck, but I want to, grow bigger. It's a startup. I was just like founded with 10 million euro for my ice cream trucks because it's San Francisco. But now we need more aggregates, we need more different, each ice cream truck needs to be able to restock, to sell, to do everything. And the question is now, I want to somehow identify my aggregates. And this is just a prototype, so we can think of what is easiest for us now. And there are many possibilities. You could put the aggregate ID, for example, into the event. You could put it into the metadata of the event. So you just have an event stream, but the information, which ice cream truck is not in the event itself. You could put it in both. In the end, I'd probably put it in both. For this thing here, I just put it in the metadata. What does it mean? It means that this was our old event store thingy. What we do now, we define an aggregate, which is just a UUID. And instead of, for example, here the append function, which just gets an event list, it gets an aggregate and an event list. And the evolve function also gets an aggregate and the event producer. So the business logic stays completely the same. I don't touch the business logic at all in this case. I just put some more information, which aggregate is this for. And what I do have now is not an event list anymore, but a dictionary from UUID, aggregate, to an event list. That's what I changed in this case. So now I have another function which is called getStream, which gives me all the events just for one aggregate. So this is our program again. And what we do here is we have trucks. This is how I create a new UUID in .NET. So I have two different trucks with a random UUID. And I say, okay, I changed self-flavor, that it's also getting a truck now. So I sell self-flavor, vanilla, for truck 1, and I also give it the event store. And I do the same thing down here. And the evolve function is getting a truck and the behavior. But as you can see here and here, nothing changed in this case in the behavior. So we just give metadata to our event store for which aggregate this is. I don't say this is the right thing, okay? Don't go out of this talk and say, Roman said, use this for metadata because it's always the best thing. It's not, all right? It's just for the prototype, and maybe this was a good idea, and maybe your colleague comes to you and says, this is not a good idea because of blah, blah, blah. So, and then you can try out. This is what I'm talking about when I'm saying prototype. Play around with it, learn about it. Where are the shortcomings and the advantages? So I just want to show you the last bit of this. We go into this thing here, step 4, and we say here it looks a bit different now. We can now use the getStream event function, for example. So I say now everything I do now is just for truck 1. And for truck 1, everything stays the same. I say self-flavor vanilla, it's not possible, restock, then exit this. And you see up there, the total history is now 3. Before it was 0. Then I do something for truck 2, exit this. And I see here, show me the events per aggregate. So it's a truck for this UUID. It has a list of 1, so it's truck 2. We just changed, so it's flavor restocked, strawberry, blah, 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 and the other history is different. But the tests are still the same, because we didn't touch the behavior at all in this case. And now you have the possibility to use different event streams within your prototypical event store application. So I think to really make use of event sourcing, we also need event streams. I'm not going to color anything more orange for now. Okay, that's enough. I can go on, I could go on, and you, if you try to do it, you could go on as well. So, but for now, that's what we have done. I gave you my motivation why I think event sourcing is awesome. I gave you the motivation why I think it's very, very important that you do it on your own. Talked about the domain, and then we just went to the steps, not really build, but I showed you an event store. You learned about projections, how you can implement behavior actually, and the testing. I hope to convince you that testing is actually important, and in the end, how can we actually work with event streams. So if you have an idea and you want to work with this, always start with the why. Why do I need this? Not because framework documentation page 35 said we need sagas, because they're awesome. Just think, does my business needs this? Do I really need this? Or can we just get rid of it for now and maybe do it later? I'm not saying frameworks are evil. If you have all your constraints and you understand how everything works together, you might find a framework that does exactly this. For example, I use those proof components, and I think they're pretty great because they are not a big framework. They give you some help down here and down there. But in our production now, we use a homegrown stuff, which has advantages and disadvantages as well. Because if you have a framework, other people are taking care of stuff as well, not only you on your own. So this is an advantage. But you need to be able to make an informed decision, I think. This is what I hope you get out of this talk. So what can we do now? We can persist the events because everything is in memory now. It's not really useful for a real application. We could put the actual error handling in there, like real argument or array, out of bound, memory exception stuff. What if this happens? We could put commands in there and go full-blown CQRS with message-based architectures. We could put some asynchrony in there. We can actually, because we recognize our projections, not our event store, but our projections get really slow. Because for each thing we need to replay all the events into some state. Let's have a read model, which is a persistent projection. Just need this, and your web page, for example, needs a specific view. Build one read model for it, etc., etc., etc. So there are many possibilities, but start with the why you need this, and implement this. So I like this book of Stephen Covey, 7 Habits of Highly Effective People. I can really recommend it. And there he says, go climb a ladder, but make sure your ladder stands on the right wall. Because it makes no sense if you're really fast climbing up a ladder and doing something, and in the end you're up there and recognize that you're completely gone into the wrong direction. So if you want to watch the F# videos, this talk in a bit longer and a bit more sophisticated version will be there as well during the end of the year. And if you want to tinker around with the code, it's down here. And if you have any questions, I will be here until 6 o'clock. And connect with me on GitHub, on Twitter, whatever. I hoped I could give you some ideas, and thanks for being here. Any questions? Nope. Yes? Sven?
Seems everything clear?
Yeah, maybe not. Maybe everything is unclear and you're completely foggy now. But I'm here, so if you have any questions later on or want to talk to me about anything, please feel free. Thank you.